If I want to lever the tin of this paint tin off, I could use a screwdriver as a lever to do that for me. So all I'm going to do is I'm going to put the screwdriver like so and use the edge of the paint tin as a pivot, and the tip of the screwdriver is pushing upwards and the handle of the screwdriver is pushing downwards, and that provides a good lever to lift the lid on the paint. So I could measure the distances on this using a tape measure to work out the moments on both sides. So the distance from the edge of the paint tin to the side of the lid is about 1 centimetre, and the distance from the edge of the paint tin to where I'm applying the force is about 20 centimetres. So if we imagine that I'm pushing down with a force of 5 newtons 20 centimetres away, I can then work out the upwards force on the side of the paint tin. These are called long handled pruners, and they're designed so that you can cut through thick branches. And they, like everything else we've been looking at in this topic, they use lever action or moments to work. So we have long arms here where we're going to apply a force, and the cutting is done down here. And this is the pivot where this bolt is. So if we were to measure these distances, you would see this is a very short distance and this is obviously a very long distance. The distance where we apply our force through our hands here is much bigger than the distance from the pivot to the cutter, and we can actually measure that. So this distance here to where we cut is 4 centimeters. So the distance from here to here is 4 centimeters, whereas the distance to where we place our hands is 75 centimeters. So we've got a distance of 75 centimeters to apply a force, and then the cutting is done here 4 centimeters away. If I want to undo a bolt, I could use a spanner like this, and the spanner uses levers to make the job easier to undo the bolt. Obviously it's very difficult to do this by just gripping it and turning, but if I use a spanner I create a very long lever. So the pivot is the center of the bolt, and the distance to the force, where the load, is the edge of the bolt. That's where I'm trying to grip. And I can use this spanner by holding the spanner at the end and applying a force from this distance to that distance. And that allows me to turn the bolt. So if I wanted to measure some distances, I could use a ruler to measure the distance to where my hand is going to be applying a force. So when I measure this, that is about 16 centimeters from there to there. So 16 centimeters to where my force is being applied, and the force provided by the spanner is around the edge of the bolt. So I need to measure from the center of the bolt to the edge of the bolt, which is 1/2 centimeter. So I have 1/2 centimeter from the center of the bolt to where the spanner is gripping the bolt, and then I have 16 centimeters from there to there. If this spanner wasn't up to the job of actually undoing the bolt, I could use a bigger spanner to produce a bigger lever, a bigger moment. So this spanner here is still gripping around the edge. So by using this I can increase the leverage, I can increase the moment. So the distance here is still about 1/2 centimeter, but the distance from the center of the bolt to where I'm applying the force is now, rather than 16 centimeters, is 23 centimeters. So I've increased the distance to the force, and I could go bigger still. I could have a bigger and bigger spanner to provide a bigger and bigger force. Pliers use a lever action to work. So when we open the pliers and want to grip something, we can grip the pliers just in this area here. and we apply a force here. And again, we can measure the distance from the pivot. So the pivot is this bit here, and we can measure the distance from the pivot to where the gripping is done. Okay, and that is a distance of 3 centimeters. So 3 centimeters from the pivot to the grip. And then the distance where we place our hands is much bigger. So this is 10 centimeters. So we've got a distance of 3 centimeters here to the jaws, from there to there, and we have a distance of 10 centimeters from here to where we're gripping the pliers. This wheelbarrow uses moments to help us move stuff around the garden or around a building site. So this is the pivot where the wheel is and the center of the axle. This is the load acting down here. So we fill this wheelbarrow up with a load, and then we apply a force where the handles are. So we lift up with the wheelbarrow like so. So when it's in action, you have the load here in the wheelbarrow, and we're lifting up the wheelbarrow here. And we can measure these distances like we've done for other applications of moments. So the distance from the center of the axle to where the load would be here is 30 centimeters. So from there to here, where the center of the load is 30 centimeters. The distance from the axle to the handles is from that axle to this handle here, 120 centimeters. So we have 30 centimeters from the wheel to the center of the load and 120 centimeters to the end of the handle. The gears on a bike use levers to make pedaling easier or harder. What we have here, this is the pivot, the center of the axle of the bike. And then we've got a small cog, which is a small distance from the pivot. So when the chain is pulling on that, the chain provides a force, and that is only a short distance from the pivot to the outside of the small cog. When we go to the large cog, we have a much larger distance from here to the outside of the cog. So if we were to measure that, the distance to the inside cog is 2 centimeters. So the distance from the center of the pivot to the outside where the chain is pulling is 2 centimeters. Whereas the distance to the large cog is 6 centimeters. So we are providing a bigger lever, 3 times the distance on the outside cog than we are on the inside cog. So if the chain is applying a force here on the cogs, the wheel, the tire, is applying a force on the road. So that's the resultant leverage we have here. So the distance from here to the edge of the rim is 33 centimeters. So the distance from the center of the axle to the outside of the tire is 33 centimeters. So we're applying a force here. So if we were using the inside cog 3 centimeters away, and that is applying a force 30 centimeters, 10 times further away. So the purpose of this is as a distance multiplier. We're looking to turn the tire many times for the small movement of the chain. So we're not looking to improve the force on this back cog. We're looking for a small rotation, a small movement of the chain to produce a large movement of the tire. One of the functions of a claw hammer is to pull a nail out of a piece of wood. On the back of this hammer is this section called the claw, and that catches the nail, and if you apply a force you can pull the nail out. And you can work out the moments involved in this, the leverage involved in this, if you measure the distance. In this case, the bottom of the hammer, the head of the hammer, is acting as a pivot, and that's why it's rounded in that way. So you can pull the hammer and the nail will come out. So the distance from the head of the hammer to the nail is 5 centimeters. So this distance from here to the pivot, 5 centimeters. Whereas where we're going to grip it on the handle is 30 centimeters. So the distance between the nail and the pivot is 5 centimeters. The handle is 30 centimeters, so that is 6 times further away. So we should get 6 times the force. And if I apply a force like so, I can pull the nail out of the wood. The pedals of a bike use a lever action to make it easier for you to pedal, to turn the wheels of the bike. So the pivot is the center of the cogs here, and obviously we place our feet on the pedals. So that is a distance of about 20 centimeters from there to the pedal. So we've got that distance, and then if we're using the large cog at the front here, then we have a distance of 10 centimeters from there to there. So it's about double the distance, which would probably double the force on the chain. So we provide a force with our feet on this lever, and that turns the chain, providing a force on the chain. Now you notice on this bike there are 2 cogs. There's an inner cog as well, and the inner cog is much smaller. So if I measure that distance from there to there, it's about half the distance, about 5 centimeters compared to this one. So by changing the cog, I can change the moment produced by the pedal. So I don't change the position of my feet, that is still the force. So if I imagine that perhaps if I'm stood on the pedals, I might be providing a force of about 500 newtons, 20 centimeters away, and that produces a force on the chain, which we can work out because the distance to the small cog is a quarter of the distance of the pedal. So it would be 4 times the force, and the distance from there to there is half the distance along the pedal. So you can work out the force that produced, and you can also see the benefits of having different cogs, smaller and bigger cogs on here, compared to the amount of force that they would produce. So I've now moved the chain onto the inner cog, so it's much closer to the pivot, and this makes it easier for me to pedal. This would be a gear you might use if I was going uphill, because I'm producing a moment on the pedal and I get a force on the chain, and the chain is now only 5 centimeters from the pivot, whereas before it was 10 centimeters.